All right, everybody, welcome back here. Hopefully we practice and understand how to simplify rational expressions. Today we're going to continue simplifying them, except today we're going to add and subtract them. Okay, so how do we add and subtract rational expressions? And again, adding and subtracting fractions. Okay, what we need to do is find a common denominator. Okay, we can't combine fractions or ratios unless we have a common denominator. Okay, so that's step number one. All right, we may need to factor things to figure out what we need to multiply by to get it in common, okay, which is why we say factor everything first. Okay, once we have common denominators, then we combine the like terms in the numerators and obviously keep the denominator the same. Okay, lastly, simplify the remaining expression if possible. Okay, just because we simplified it and cleaned it up doesn't mean other things are going to cancel out. Sometimes it does, sometimes it doesn't. Okay, so let's do some examples. We'll see kind of a mixture of some that do and some that don't. Okay, so here, the first question here. We have common denominators already. All right, so what we're going to do is keep the denominator the same and then just simply combine the numerator. So 12x and 3x is 15x. And then we have 5 and a negative 2, which is a positive 3 over 3x minus 1. Now, some people would just, circle that box, move on. We have to make sure everything is fully simplified. I see a greatest common factor in the numerator. Okay, will that cause us to be able to simplify if we can yank that out? Okay, only one way to find out is to actually do it. So there's a 3 in there. All right, so I got everything broken down in factored form. I cannot simplify it further. However, I can still do my domain restrictions. X cannot equal 1/3. Okay, so there's the first one. All right, question number 2. Okay, 13a squared over 2a minus 3a squared over 2a. All right, I already have common denominators, 2a and 2a. So just combine the numerators. 13a squared minus 3a squared is 10a squared over 2a. Now, I know that a cannot equal 0, okay, right here. But I can also divide some things out, all right? 10 divided by 2 is 5. And then a squared over a is a. So my answer is 5a, where a cannot equal 0. All right? So two pretty simple ones where we already have the denominators the same. Okay, what happens if we don't have common denominators? Well, we have to force it to be common denominators. Okay, so looking at this next one, our denominators are 2x and 3x. So we already have an x in common here, right? All right, I can turn a 2 into a 3 and a 3 into a 2. So I'm going to multiply by a giant 1 here. Okay, of 3 over 3 for that guy, and a giant 1 here of 2 over 2. All right, so that gives me 45 over 6x minus 32 over 6x. Now my denominators are the same, so I can proceed. 45 minus 32, clean up our numerator here. Okay, it's 13 over 6x. And x cannot equal 0. All right, so nothing more I can do with that because 13 and 6, no common factors in there. Okay, all right, let's look at this next one. All right, so as we look at this, okay, how can we get common denominators? I got this, this trinomial over here. Okay, that's why we say factor it first. All right, so my left side, I can't really do anything with. All right. My right side denominator, I can factor that. So what multiplies to 24 and adds to be 11? Okay, that's 8 and 3. So y plus 8, y plus 3. All right, now I can inspect this further and say, okay, what do I need to have common denominators? I already have a y plus 8. All right, so I need to give this left side the giant 1 of a factor of y plus 3 over y plus 3. Okay, now my denominator should be y plus 8 over y plus 3 for both of them. Okay, so I distribute this. That's 7y plus 21 plus 35 over y plus 8, y plus 3. Okay. Lastly, I keep my denominator the same, so I know it's going to stay y plus 8 times y plus 3. And my numerator, combine like terms there, nothing to combine with the y, but the 21 and 35 makes 56. Okay, that is not our final answer because I have a greatest common factor in my numerator. Okay, I could pull out a factor of 7. So if I pull out a factor of 7, that gives me y plus 8. Okay, so I'm looking ahead and I can already see the y plus 8's cancel out, but I want to do my domain restrictions. X can't equal negative 8 or negative 3. Cancel the giant ones out. 7 on top, y plus 3 on the bottom. Okay, so sometimes things cancel, sometimes things don't. Okay, but there's only one way to figure it out, is to actually try it and do it, factor everything completely and see if anything does, in fact, simplify further. All right, let's try 2 more. Okay, so we got lucky up here with the expression on the right. We only had to multiply one side by something. Okay, what if we had to multiply both sides by something? All right, so the common denominator between b plus 3 and b is b times b plus 3. So I need to give this the factor of b, and I need to give this side the factor of b plus 3. All right, so my left side is now b squared over b times b plus 3 minus, I'm going to do plus a negative 4 times b plus 3. So we could distribute that. Okay. And before I, walk away from this, let's see if we can factor it. Okay, so my numerator, what multiplies to be negative 12 and adds to give you negative 4? Well, that's negative 6 and positive 2. All right. And no common factors. So b can't equal 0 or negative 3. So that would be my final answer there. Okay, some people always question, which way do you want your final answer? Do you want it in all factored form? Do you want it all multiplied out? Like, should we multiply this as b squared plus 3b? Okay, there's a lot of ways you could see it, but the only way to know that it's fully simplified is to be in factored form. Okay, I'm not going to require you to multiply it back out. Some answer keys will have it all multiplied out. Some PSAT, SATs will have it multiplied out. You just have to know to put it in the appropriate form, okay, to match, a possible answer. Okay? All right, let's squeeze in this next question here to the right. All right, so looking at these two, I don't know what my common denominator is. Are there any common factors already hiding in there? The only way to find out is to actually factor it. So pull a common factor of 2 out of there. Okay, I'm going to do plus negative 8 up here. That way I don't forget my negative. Pull a greatest common factor of r out. So if we look at this, I already have a common factor of r plus 4. All right. So the only thing I have to give the right one is the factor of 2. And the only one I have to give the left side is the factor of r. Okay, so now both my denominators would be 2r times the quantity r plus 4. All right, so I can squeeze my numerator together. R squared minus 16 over 2r times the quantity r plus 4. All right, I recognize my numerator is a difference of squares, so I can do my shortcut r plus 4, r minus 4. So now I'm going to do my domain restrictions. R can't equal 0 or negative 4. And then I can cancel out my r plus 4s. So my final expression here is quantity r minus 4 over 2r with my domain restrictions. Okay? So again, the most important thing here is making sure that you are getting common denominators before you squeeze the expression together. Before you do any addition or subtraction, you need common denominators, okay? And just like our last example, factor it first to see if there is anything already in common. That way you're not giving it something that, you know, you're going to give it a factor of something you're going to have to simplify later. Okay, that's just creating more work for yourself. Okay, so we'll have an opportunity to practice some more of these the next time you return to school. Okay, continue to be factoring machines. All right, continue to follow the rules. Don't make any of your own rules up. And we'll give you guys an opportunity to practice next time. Thanks for tuning in.